Host A and Host B were placed into different VLANs due to security requirements. However, they can communicate, investigate, and resolve the issue if possible. Take note here that the management network is the 10.1.1.0 network. It is safe to assume that the issue is between the switches, so we'll log into them first. We will do this by first logging into the admin PC. From the admin PC, we will SSH into switch 1 at 10.1.1.1. The first step should be to verify the VLANs that are assigned to the associated ports connected to the PCs. This could be shown by running the show run commands, but as you see, and as I've explained on my webpage, I disabled that. While it is a valid troubleshooting step, I want to ensure that learners are aware of the various other commands that can display valuable information about the operational status of a network device. Commands like the show interface status command. It reveals a wealth of information, like the port status of connected, disabled, or not connected. It can show if a port is routed in the case of layer 3 switches, or the VLAN assignment for regular switch ports, and help resolve issues related to physical things like speed. We take a look and see that the port that host A is connected to is FA01. We take a look at the VLAN assignment of FA01 and we see that host A is assigned to VLAN 10. Let's take a look at switch 2's FA02 port, which is connected to host B. Using the show interface status command again, we can see that host B is assigned to VLAN 20. If host A is in VLAN 10 and host B is in VLAN 20, how is it that they're able to communicate? The first troubleshooting step should have been to verify the validity of the complaint. Let's take care of that now by testing connectivity between host A and B. I log into host B and issue a ping towards host A's IP. It is successful, validating the complaint. But we need to figure out why these two devices that should be segmented are actually communicating. I hop back into the admin PC. Let's check the trunk between switch 1 and switch 2. I will do this by issuing the show interface trunk command. That's interesting. It appears that no trunks have been configured. This can also be confirmed by checking the output of the show interface status command. If a port had been configured as a trunk, we would see that under the VLAN column. We will also check switch 1 for the trunk status. We are seeing the same things on switch 1 that we saw on switch 2. What happened to our trunks? And how are host A and host B communicating if those aren't even configured? Our host, A and B, connect to switches on access ports. As the name suggests, these ports act as the doorway for endpoints to access the network. These ports start off, by default, in VLAN 1 and can be assigned to other VLANs, 10 and 20 in our case. The ports that will connect the switches are assigned to the same VLANs as the respective hosts. Host A generates a broadcast and sends it out. It reaches the switch, which processes it and forwards it out all ports in the same VLAN as the port connected to host A. This is VLAN 10. The frame arrives on a port assigned to VLAN 20 on switch 2, so it must be for VLAN 20. Switch 2 forwards it out the port, and host B receives it. This is what's known as VLAN hopping, and it's actually a vulnerability. The way this can be fixed is by making the ports between switch 1 and switch 2 trunk ports. In this way, any frames leaving will be tagged with either VLAN 10 or VLAN 20, and when it gets to the other switch, it will be placed into the correct VLAN. Host A and host B will no longer be able to communicate. They will be segmented. I realized after the fact that in my quest to prevent learners from using the show commands, I inhibited the ability to issue other commands. I've found that this is a limitation in Packet Tracer, as the associated privilege commands cause no issues in my CML and even glabs. For now, you can just watch along. On each of the switches, I issue the switch port trunk encapsulation.1q command. This tells the switch which encapsulation method I would like to use. I again issue the show interface trunk command, and you can see that the interface is now a trunk. I log back into host B and initiate a ping towards host A. As you see, it fails. Our problem has been solved.